right.
Okay, hey guys, you guys are going to be doing an activity with matrices. Mr. Ingram is going to hand you each a set of papers, and Mr. Ingram, this one's for you. The papers are sorted, kind of staggered. There's like 3 or 4. That's one person's set, and then the next set is for the next kid. So everybody will have a set of papers. We talked about matrices already, so really we're just going a little bit further. We're going to do things with them now. Instead of just taking words and writing information in a matrix, we will actually add them, subtract them, scale them up, scale them down, and that's it. So the words we talked about already, and we already should know, are the dimensions of matrices. Here on the board I have an example of a 2 by 2 matrix. We name them according to their rows by their columns. So this one has 2 rows that run across. And remember we talked about rows are across, columns are this way or this way. Yes? Okay, so 2 rows by 2 columns. Alright? So that will make a difference because when you get to your notes, you'll see where you have to add matrices, and there are specific rules about when you're allowed to add them and when you can't. So if they're not the exact same size, then you cannot add them together. Same thing goes for subtraction. Alright, so entries was another word we talked about before. Can you get there? Alright, entries. So here I have one entry. This is the entry in the first row and first column. This entry is 2x. Here is another entry in the first row, second column, and so on. This word may be new. We talked about it a little bit before, but corresponding entries basically just mean the entries that are in the same relative position, inside the brackets in the same spot. So here, this first entry, 2x, corresponds with this entry in the other matrix, which is a 10. So 2x and 10 are corresponding entries. When you start to add on your notes page, you'll see it says you have to add up the corresponding entries. Same thing with subtraction. So for instance, if I were trying to add these matrices together, I would have to add the 2x to the 10 and write the answer down in row 1, column 1 of my answer. If I want to add, I would say 3 plus 3, and I would write the 6 in row 1, column 2 of my answer, and you'll see that stuff on your notes. The last thing I'll say before I get out of here is that notice you see I have one matrix set equal to the other matrix. And so if somebody tells you that this matrix is equal to that one, it means they're exactly the same in every way. So each entry has to be worth the same amount or they're really not equal. And you can see that here, that I have 3 and 3 in the same spot. I have 5 and 5 in the same spot, but you guys on your notes will solve to figure out what x has to be to keep the 2 matrices equal. If they're really equal, then this circle should be a 10, just like this entry is a 10. And your job will be to figure out, how can we make 2x really equal 10? You guys can solve a one-step equation, and so you will tell me that x must be 5. Okay? So if x is 5, you'll solve for the missing variables using what you know about 2 matrices that are equal. The corresponding entries have to be equal or they're not equal matrices.